6 in my GCSE revision series. This episode we'll be looking at vectors, a really difficult topic to do. This particular topic suited to those of you that are doing higher tier GCSE mathematics only, because this topic is testing vectors, which is a high tier topic. You only want to be looking at this, please, if you're doing that higher tier. Again, just in case you're new to these videos are really to try and help people working towards their GCSE mathematics in the summer. The idea is that you watch these videos, they're short, sharp videos, designed to be sort of less than sort of 40 minutes long, about half an hour long or so, just giving you some good introductions into the topics, past paper questions, ideas and suggestions for you to follow. If you want to look at the topics from scratch, there are loads of videos on YouTube for you to look at. And if you want me to look at any other topics, please do so by leaving comments in the comment section below, which I'm leaving live for this video. Also, if you're watching this on Twitch, you can look at the chat section, which is next to the Twitch channel, which you can again suggest future topics for me to do. So, we're going to get cracking on with these vector questions. I've picked out a few for us to look at, but the key thing here is I want to go through them in increasing levels of difficulty. So these particular questions are pretty stock questions, but they do get increasingly difficult. What I'm trying to show with these questions is that the principles remain always the same. If you follow the same principles, you'll always get these questions right. So it's important to follow the same methodology, the same rules. Just look at how you're following these questions. It's quite difficult to print these out in a way that you can see the whole screen here, so I'm going to try and move it around so you can see what's going on. So here is a quadrilateral, which I'll show you at the top here. This quadrilateral, so A, B, they describe it as CAYB, and you've got these vectors filled in for you. Quite useful for them to put the vectors in for you. Again, just a reminder that if they use emboldened text in the GCSE papers, and they will do so, that really means 3A written like this with an underline, so 3A underline, and it's useful when you're answering to use those underlined phrases. Don't ignore the underlines, because it's important that you recognise that these are vectors, and vectors should be underlined with small letters. This is asking you about a point X, so they're saying X is the point on AB, so that's this line here, so A to B, such that AX to XB is 1 to 2, and it's asking you to prove something. So basic principles, again, I'm going to try and go through all these questions with the same basic principles for you. So here's the first basic principle. If you see something given to you, first of all, make sure all of the vectors in the question are filled out correctly, which you have, but then also, if you're given a question, part of the question that asks about a ratio, always try and draw those points in. So AX to XB, so that implies the distance from AX, which I'm just supposing is up there, AX to XB, so I'm going to put that point here as X, AX to XB, and again they're saying this is 1 to 2. So the first thing to do is to share out this line. If this is shared out in 3 parts, one of those parts is for AX, and then 2 of those parts is for XB. So you can see that I've put 1/3 and 2/3. So that's the first thing to do. If you're given a ratio, fill out the sections that you need with the ratios that you're given. The next principle to do, before we even get to the question, the next principle here is to try and find a vector that goes from A to B, because I guarantee you're going to need it. In answering this question, you're going to need it. You need a vector that goes through this line. So this line, 1/3, 1/3, 2/3, that's split up, you're going to need to know that vector, because there's no way they would give you this unless you needed it. So we're going to work out a vector for AB, simply because it's alphabetical order and it's the way they say it in the question. So I'm going to put AB together to show you that you need that line, and I guarantee you that when we do this proof later, you're going to need this vector. So whatever vector you've done, so you've drawn in the 1/3 and the 2/3, we're now going to work out this line AB, which is definitely something you're going to need later on. So I'm going to work out the vector AB, and that's going to be from here to here. Now again, I can't get there straight because there's nothing that tells me how to get there straight, so I need to make a vector triangle that travels from A to B in a roundabout way. So where's my vector triangle going to go? With the vectors I've been given in the question, I can go from A to C to B. So I can go a roundabout way, A to C to B. To go from A to C, it's minus 3A, because this is 3A from there to there, so the opposite direction must be minus 3A. And then to go from C to B, it's just 6B, so I'm going to add on the 6B. So that's a vector from A to B is minus 3a to 6b. Now, let's look at this proof. He's asking you to prove that cx, in other words, from here to here, is 2/5 of the distance, or the vector that goes from c to y. So c to y, which is over here somewhere. There's c to y. Now, let's work out a vector for cy first of all. That would be quite handy, because we can do that based on the information we've been given in the question. So cy I'm going to write down. Now c to y, again we're going to follow a vector proof. We're going to go from c to b, and then from b to y. So we're going to go from c to b, 6b, and then this bit up here, so 5a minus b from that bit up there. I'm just going to follow the vector triangle. Now, we can gather together some like terms. So 6b minus b is 5b, and then we've got 5a. Just because I'm a pedant, I'm going to write that in alphabetical order, just because I prefer to write it in alphabetical order. 5a plus 5b, I'll write it like that. That's cy. So we've got the cy part. We need the cx part now, so let's see if we can work out cx. Again, I'm going to write this just to show you, just real quick down here. Okay, now I can write an expression for cx. So to go from here, cx, to there, so c to x, I've got to go from c to a, and then from a to x. So c to a first of all, and then a to x next. So the ca bit is easy, because that's just 3a. The a to x is not so straightforward. A to x is 1/3 of the distance from, or the vector from a to b from earlier. So I'll just bring it down to show you. So bring it down a bit more. So that a to x is 1/3 from there to there. Now earlier we worked out AB, remember? I told you you'd need it. So here's AB from earlier. This from there to there is 1/3 of this. So 1/3 of that. So we're going to put down from a to x, it's 1/3 of this expression that we got earlier. So minus 3a plus 6b. Okay, and we're going to add these two things together and gather together like terms. Now this is just like multiplying up brackets, just like with algebra. It's just that you've got these a underlines and b underlines, so just treat them the same. So we're going to multiply out the brackets first of all. I'm going to do this real slow because a lot of people do get this really confused. So minus 3 times 1/3 is minus 1a. Okay, so I hope you understand that. So minus 3 times 1/3, we're multiplying out 1/3 times minus 3. 1/3 times 6, so 1/3 times 6 is 2b. Again, just multiplying that by that. Okay, it's just like algebra. And then this phrase down here, 3a minus a, we're going to gather together like terms. So that's 2a. And then we've got 2b here. So 2a plus 2b. So 2a plus 2b. Now, if I take out what's common, that's 2 lots of a plus b. And earlier on we got from cy is 5 lots of a plus b. And therefore we have shown that cx, this one, is 2/5 of this. Because you can see if you divide this by 5 and multiply it by 2, you'll get the same thing. So we've actually shown that. So we can say that we've shown that lastly, just to say that we've done it. And we put the two lines to say as proof. So therefore cx is 2/5 of cy, because you can see they're related. This and this are related. This here is 2/5 of this. You would divide by 5 and multiply it by 2 to get back to this. So you've shown it. You've definitely shown it. No problem at all. Okay, this second question now. Just need to get it on the screen a bit better. So there you go. Second question now. So this is a slightly different question, but again, some of the things that I talked about in the previous example are still relevant. So first of all, we're going to look at the questions. So it says OAB is a triangle, so triangle there. A is the midpoint of OZ. Okay, the minute they say that, I'm going to write in that this is a half, and that's a half. Okay, and Y is the midpoint of AB, so this bit here. So again, this is a half, and that's a half. So just like the earlier question, we're going to write in the ratios when we're given them. X is a point on OB, but it doesn't say where X is. It does. I did say earlier you need to put in where you have got vectors. So OA is A, so this vector here is A, to there. So from there to there is A, and then OX is 2B. So again, That's 2b, just from there to there. And then xb is b. I'm writing that in. So all this information from the question I'm just writing in. Now, again, principle from earlier, I did say that when you've written ratios in an unknown line, you are definitely going to need that unknown line at some stage. So you're going to need to think about how you write these vectors out. So it'd be quite useful to understand what this vector is here from A to B, because we have got this unknown vector. And similarly, it'd be also useful to know from O to Z what that vector is, because we haven't got that either. So O to Z is easy, because O to Z is just double this. If that's A from there to there, this must be 2A from there to there. So that's really easy. This one, though, is not straightforward. A to B. So we're going to write the vectors just like earlier, the earlier question, if you remember, we wrote the ratios down and we worked out what the vector was. And this, again, we're going to do the same thing here. We've written the ratios down, we're going to work out what this vector is, A to B. Again, alphabetical just because I want to do it alphabetically. I guarantee you we're going to need this vector in a minute. So A to B, again, following through my vector triangle, I've got to go from there to there to there. So A to O, that's the opposite of this, so minus A, and then from there to there, well, it's 2B plus B, so it's plus 3B, so minus A plus 3B. We're going to need this vector in a minute, I guarantee you. Now, let's have a look at the question. It says, prove that XYZ is a straight line. Now, when you get a question that asks you about things, vectors on a straight line, all you've got to do is follow this basic principle. You'll look at X to Y, you'll look at X to Z, and then you'll show that these two things are parallel, and because they have a point in common, the X, once you've shown they're parallel, that must prove that they're on a straight line. So that principle again, same principle all the time, for straight lines anyway. Find the vector from X to Y, find the vector from X to Z, show that X to Z and X to Y are parallel, and then because they go through the same point, the X, that must prove that they're all on a straight line. So that's the principle we're going to follow. So let's get an expression first of all for X to Y. Okay, so from X here to Y. Again, we're going to go find my vector triangle. So go from X to Y, I'm going to go B first of all. So from X to B, and then we're going to go from B to Y. That's my vector triangle I'm going to make. Now, X to B, I'll move that slightly up. X to B is just B, little b, and B to Y is half of B to A. Now, this was AB from earlier. I told you you'd need this vector. So B to A is the minus version of this. So I'm going to put half of this, but I need to put it the other way around because I've got to put this is AB. So, well, I'll just write it BA just to show you. So BA is going to be A minus 3B. So it's just the two signs have been reversed because we're going in the opposite direction. So this is going to be half as much of that distance from there to there. So it's half of this. So half of A minus 3B. Okay. Then we're going to gather together like terms, but just like earlier, I'm going to very carefully multiply my brackets first. So half times A is just half A. Half times 3 is minus 3 over 2. Okay, B. And we're going to gather together like terms. So we've got 1B here, minus 3 over 2B. So that's 1.5, isn't it? So 1 minus 1.5, that's minus a half B, plus a half A. And again, I'm going to write that in alphabetical order. So half A minus a half B. Sorry, I didn't show that. So half A minus a half B. I'm going to take out what's common. Just the same. This is almost exactly the same as the previous question, really. We're taking out the common. So I've got half. The expression for X, Y is half A minus B. So I found the distance from X to Y. To show you that real quick, from X to Y, that's half of this. Now I need to find the vector that goes from X to Z. So I'm going to do that real quick. So again, X to Z, very simple. Up to there, to O. Sorry, to show that real quick. So up to O, and then from O to Z. We found OZ earlier. OZ was 2A. If you remember, that's the A, and this is half again. So this is 2A from O to Z. So we're going to do from X to Z. That's from X to O, and from O to Z. So again, I'm just writing down my triangles that I need. Just showing the examiner everything that I need. So X to O is minus 2B. Why is it minus? Just take a second. If this is 2b from there to there, then it must be minus 2b to go back up there. So minus 2b. And then the OZ bit, we discussed that earlier, is plus 2a. And again, I'm going to write this in alphabetical order, and I'm also going to take out what's common. So I've written it in alphabetical order, I've taken out what's common. Now, you can see that this expression here is a multiple of this. So you can see that this is a multiple of this. So you can see that xz, and it's 4 times, isn't it? You can see that 4 times, because 4 times a half is 2. So xz is 4 lots of xy. So we've shown that these two are parallel. That proves they're parallel. One is a scalar multiple of the other. That shows that they're parallel. Okay, so that shows parallel. What also we're going to say is because they share a point, in x, that must imply that they are indeed collinear or on a straight line. So we're going to show that that's collinear and put that we've shown that that's proved. Okay, this next question, same thing again really. Just trying to do the same thing again, all the way through, same principles I'm going to follow all the time. Just going to try and show you that the rules are the rules, no matter which principle you're given, which problem you're given, the rules are the rules. So we're given OPTR, it's a trapezium. We've got A, B and 3B. You're going to check that all of those are filled in, they are. Find OT in terms of A and B, first of all. So OT, we're going to go from there to there to there. So A plus B. Again, don't forget your underlines. Okay, so A plus B. Then we're going to do find PR in terms of A and B. So PR, where's PR? Let's have a look at that. So PR, again, making a vector triangle, I'm going to go from there to there to there. So PR is PO plus OR. So there's my vector triangle. I'm just showing the examiner what I'm doing. So P to O and then O to R. So I'm showing that, P to O and O to R. PO was minus A. Let's show that again. It's the opposite of this. And then O to R is 3B. So that's 3B minus A. Now this last bit says S is a point on PR such that PS to SR is 1 to 3. So again, same principle. How many bits are we splitting that line into? We're splitting it into 4. So if we go back up to PR, we're splitting it into 4. So I'm going to put a little point there and call it S. Put a little quarter in there and a 3/4 in there to show that that's my thing. And just like earlier, before I even go anywhere, I'm going to work out the vector from P to R, because now I've got these two unknown ratios. I'm going to work out the vector PR because we're definitely going to need it in a minute. So we're going to do the same principle. Once you've written down some stuff, we're going to write down this vector PR and we're going to work out what that vector is. So because I know I'm going to need it, I'm going to write PR. So PR is, again, well, we had it from earlier, didn't we? PR, we actually wrote down from earlier, didn't we? PR was minus 3B minus A. Oh, sorry, 3B minus A rather. So PR is that. So we definitely have it from earlier, but we're going to need in a minute, I'm sure, PS or SR. So we've already got the vector PR, which is helpful. And we're going to try and work up the questions asking us now. So saying, find OS. So find OS. That's from here to there. So we've got to go, alright, so O to P. So OS, which is what we're asked for, is O to P plus P to S. I'm only writing it up here just because it's easier than flicking top and bottom all the time. So O to P and P to S. So O to P, first of all, is this vector, A, and PS, this vector here, is going to be a quarter of this vector PR, so a quarter of that. So a quarter of this 3B minus A. Okay, I'm going to go back down the bottom again just because that's where the answer is supposed to be. So I'm just going to copy that phrase out that we just had. Okay, and again, I'm going to very carefully multiply out my brackets. I'm trying to really take my time on these because this is where people go wrong. And a quarter A, and then gather together my like terms. So I've got 1A here, minus a quarter A, so 1 minus a quarter, that's 3/4 A. And then I've got 3/4 B. So, straightforward, not a problem. Now, last of all, I want to show you the hardest question I've ever seen on vectors. This question was one of the last questions on the November 2015 exam, so you can see that here. It's coming through as a sort of triangle question, and it's talking about straight lines. M is the midpoint, and so on. So it's lots of information here. Apologies for the smallness of the writing, but I'm going to try and make it a bit clearer for you. So OA is A, nothing filled in, so you can see nothing's filled in. So a lot of that stuff, but it is question 21, so it's the second last question of the paper. So it's meant to be hard, and it was a non-calculated paper as well. But I want to show you the principles I've just been going through on those first three questions. It's the same principles here, so we're going to go through the same principles again, and we're going to get this right. Even though this is a much, much harder question, we're going to do exactly the same things as we did on those earlier questions. So, just real quick, I'm going to go through and just sort of establish again one thing at a time. So this one thing here says M is the midpoint of AB. So this M is the midpoint between there and there. So again, the first thing I'm going to do is put a half and a half. Okay, so I'm going to do that. Then it says OA is A and OB is B. So this whole thing here is B from there to there. And it says OP to PM, so OP to PM, 3/2, so that's 3/5, and then 2/5. Okay, just like earlier, how many bits are we splitting it into? 5, so that's 3/5 and 2/5. Okay, so I'm filling that all in for you. So then it says, work out the ratio O to N to NP. Okay, so just like earlier, we're going to start by working out all of the things that we have yet to work out. So we've got this half and this half. I don't know anything about A to B, so I'm going to need that vector later. So I'm going to write out A to B, because that's what we were doing earlier. When we wrote down some ratios, we try and work out the vector A to B. So I'm going to work out A to B. Now A to B is minus A plus B. You can see that. So it's just from there to there and there to there. So minus A plus B. Straightforward. Then I'm going to write down A to M, because that would be quite useful. So A to M, that's half as much of that distance we just did. So half as much. So I'm just writing down some things here to be helpful. Again, there was another line that I wrote some ratios down on this line here from O to M. So it'd be quite good to work out what O to M is. I guarantee you're going to need it. So we're going to do the same thing again. We're going to work out O to M. And the O to M is from here to here and then from there to there. So it's A and then from A to M. So it's plus this bit, plus the half of minus A plus B. Again, I can show some simplification, so I'm going to show a simplification real quick. So I'm going to multiply up my brackets very carefully and show that simplification. Okay, so getting half A plus a half B. Okay, very simple so far. So next thing I'm going to do is I'm going to try and work out what O to P is, because I don't know what O to P is. So let's try and work out what O to P is. Again, that's 3/5 of this thing up here. So 3/5 of this. Okay, so 3/5 of that. And then we're going to do multiply out all these things. So 3/5 of this multiplied out is going to be this. And then 3/10 of B. So we've got 3/10 of A and 3/10 of B. Okay, so I've written quite a lot of information there. I haven't even touched the question yet, but for the time being, that's what I'm going to show. Now, it's asking for the ratio O to N, so from here to here, and then the ratio N to B, from there to there. Okay, we don't really know what's going on at the moment. We're sort of a bit interested to find out. I'd like to know how the line's been split into bits. It'd be quite useful to look at the line that's going from A to N. I don't know what a to n is yet. I'd quite like to know what that is. So a to n, okay, you can see there's going to be some expression for it. So a to n from there to there. How do I get from a to n? So I go minus a plus some multiplier of b, because I don't know how much that's splitting up b. That's kind of what I need, really. I kind of know it's minus a, but then some multiplier of b. Let's just call that, I don't know, x. Okay, so minus a plus some multiplier of b takes you to this place here. That's what the expression an is. So that's one vector a to n that we can get, one vector expression for a to n that I can get. Now the other thing worth knowing is that we can work out what a to p is. A to p, we can actually work that out. A to p. How do I get a to p? Well, that's going to be a to o and an o to p. So you can see that, a to o and an o to p. Okay, a to o is minus a, and an o to p, we worked out earlier, is this stuff, 3/10 a, and then 3/10 b. Okay, now this from here to here, again, if I gather together like terms, I get minus 7/10 a and then 3/10 b. That's a to p. Now I know that an, if you look at an and ap are parallel lines, but they're also on the same straight line. A to n is on the same straight line as a to p. So just like the previous question, I know that an here, this whole distance, so an is equal to some multiple, let's just call that y, of ap. So some multiple of this. We know it's going to be some multiple. We don't know what that we don't know what y is, but we know that a to n is going to be some multiple of ap. In other words, a to n is equal to this multiple y, which I gave it earlier, this. So minus 7/10 a plus 3/10 b. We know that. Okay, so minus 7/10 a plus 7/10 b, that's this expression, but times this by this scalar multiple y. Now earlier, I wrote down another expression which gives me an. So these two phrases, I'm just going to put stars next to them so you can see them. So this is one of the expressions I wrote down earlier, minus a plus xb, and this one, y lots of blah 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 blah, and you can see these two things, but they're both the same. We know they're both the same. This is important. Now if you look at the coefficients of a, this coefficient of a here is minus 1, and this coefficient of a, once we multiply the brackets, will be minus 7/10 y. Minus 7/10 y. So that's quite an important little thing we're looking at there, that we know that minus 7/10 y and minus 1 must be the same. So I'm just going to bring in a bit of blank paper here because I've run out of space a little bit. But we know that minus 7/10 y equals minus 1, because the coefficient of a here must be the coefficient of a there. That means that y is minus 1 divided by minus 7/10, which is 10 over 7. So we found our y. That's quite an important little fact. Now again, if you look at the coefficients, if we multiply the brackets, 3/10 y is the coefficient of b on this one, and the coefficient of b on this one was my x from earlier, which we don't know. Okay, so the coefficient is y. But we do know y now. We know that y is 10 over 7. So if you put 3 over 10 times 10 over 7, that's going to be x. And that gives you 30 over 70 is x, which means x is 3/7. Now what does that mean? If you go back to the example earlier, if you go back to the slide, we know now that the proportion, I said this was ON, I said that ON was a proportion, this X was how much of B we were using. So if this is 3/7, which we've just worked out, 3/7, just show you that again, show 3/7, that's 3/7, this must be 4/7, okay, because the two things have to add to 1. If that's 3 and that's 4/7, that's 3/7, that's 4/7, as a ratio, which is what we're asked for, it will be 3 to 4. Okay, so 3 to 4. 3 bits, 4 bits, 3 to 4. That's the answer they're looking for. This is the hardest question I've been able to find on vectors. It's absolutely difficult to do, but principles are very similar to some of the previous questions we did. What did we do? Really, we just looked at where we were writing down numbers, working out the vectors that we needed, and it was just stepping our way through the problem. We had to use these x's and y's, which was really horrible, but I hope that you understood that principle that we were doing. We're just looking at these values, working our way through, understanding what was going on and trying to make it work. The key thing to mention here is it's worth 5 marks. It's a lot of marks, so it's well worth your while thinking through these sorts of problems. Okay, that's the end of vectors for today. I hope you enjoyed that video. If you're working towards your GCSE mathematics in summer, I wish you all the best of luck. If you could leave a like or a subscribe and leave a comment in the comment section below, that would be really helpful for me. So if you want to click like and subscribe, that would be really helpful. If you want to catch other videos, just have a look at the Maths Jedi channel on YouTube. And if you want to leave a comment in the comment section below, but please be nice. Okay, I hope you have a really good rest of the week, and I'll see you soon. Bye.